Okay, welcome back everybody. We're skipping from exponents 2 to exponents 4. I'll explain that later, but we are doing exponents 4 and we're focusing in, we already talked about zero exponents, we're going to talk about negative exponents. You will be able to simplify expressions with zero and negative exponents and evaluate exponential expressions. Hopefully in class you watched a little video called the vinculum family in class, and this is the proof about negative exponents. If we have a to the negative n power, a negative exponent really means reciprocal or change your position. So an example I have is if I have 8 to the negative 2 power, that negative on the exponent tells me to do the reciprocal of 8. Now the reciprocal of 8 is 1 over 8. So basically that 8 has to change positions and go down to the bottom. But when it does that, the 2 becomes positive. So 8 to the negative 2 power equals 1 over 64. Now, if I just said 8 to the second power, that would equal 64. So notice the difference between these. A positive second power gives me a whole number, 64. But if I do a negative exponent, that really makes it a fraction, well, or really sends that 8 to a different spot. So, we're going to explore this more later in the video. Okay, let's start with just a single base and an exponent. So 4 to the negative 3 power. So we have to get rid of all negative exponents when we simplify expressions. So the way we do it again is we flip the base. So the base is 4 over 1. We flip it and make it 1 over 4. And then that exponent that's on the 4 stays with it, but it becomes positive. Now, we need to say what that equals. So that means 1 over 4 times 4 times 4. So that equals 1 over 64. That's my answer. Alright, next, on our next one we have 3 to the negative 4 power. Again, negative exponent. So we have to do the reciprocal. So that's going to equal 1 over 3 to the 4th power. So we're going to have 1 over 3 to the 4th power means 3 times 3 times 3 times 3, and that equals 81. So that's the final answer I do want you to write after you flip it. Now, this is a review from the last video. Zero power. Anything to the 0 power equals 1. So this entire parentheses, it doesn't matter, is to the 0 power, so it equals 1. Doesn't matter what's inside the parentheses. Okay, here we have a negative 3 to the negative 2 power. So what I'm going to do is put that over 1, and I'm going to flip it because of the negative 2. So I get 1 over negative 3, and then to the positive 2 power. Now, I'm not done yet. I'm not done because I have to do this. That means a negative sign with 3 multiplied to itself. So that equals 1 over negative 9. And I don't know if you remember from 7th grade, the difference between, real quick here, if I were to do negative 3 squared and negative 3 in parentheses squared, this first one is going to be negative 9 because it's really 3 squared and the negative just sits there and waits. Okay, or it's technically order of operations. You do exponents, and then this is like a minus sign, and you do that last. So this equals negative 9, where if I have this with a parenthesis, that means write the parenthesis negative 3, write that twice. And when I write that twice, I have negative 3 multiplied to negative 3, which gives me a positive 9. So just to show you again, this one is positive, this one's negative. And that's why this was negative, because this 3 does not have a parenthesis around the negative. Well, let's get back here. So here we have negative 4 to the negative 3rd power. So again, I will take it and I will flip it. So I'll say 1 over negative 4 parentheses positive 3 power now because I put it in the basement. So that would equal 1 over, and now we're going to do negative 4 multiplied to negative 4 multiplied to negative 4 because it has the parentheses. So negative 4 multiplied to negative 4 multiplied to negative 4. That will equal negative 64. So my final answer is 1 over negative 64. And lastly, we have another zero exponent, and we know that zero exponent always equals 1. Hopefully you remember from the other video I did, and I said something about things not being glued together. So important, so important. So let's start by reading, and then I'll bring that up again. An algebraic expression is in simplest form when it is written with only positive exponents. So when you're all done, your exponents have to be positive. So this one's not done, this is not done, this is not done. These are not done because they have negative exponents. If the expression is a fraction in simplest form, the only common factor between the numerator and denominator is 1. In other words, reduce all fractions. So let's do this first one. Remember, these are not glued together, so you have to remember that. This 6 has an exponent of 1. So because it has a positive exponent, this 6 will stay on top. But this m to the negative 2 needs to flip. Okay, so that m to the negative 2 needs to flip and change positions. So it needs to go to the basement. When it goes to the basement, it is positive, and now it's okay. Okay? So remember in the vinculum family, this is a bad attitude. Bad attitude, you better change floors. So go to the basement. Now you have a good attitude. Okay, right here, the 2 has a positive 1, so it can stay. If you have a good attitude, you can stay. But the 3, horrible attitude. So because it's underneath, it's going to move up. It's going to move up above the vinculum, and it's going to come up here with the 2, and now it will be positive. Okay? The negative made it change positions. Let's do this one. I see we have a 1 on top, and we have a w to the negative 4 power on bottom. Well, it's a negative exponent, so because it's negative, we have to change its position. Alright, so that w to the negative 4 power has to change its position from being in the basement, and now it has to go upstairs. So it will go upstairs, and it will be w to the positive 4, okay? And there's my answer, w to the positive 4. You can also say 1w to the positive 4 because the 1's there, but you do not have to write the 1. Okay, remember, not glued together, not glued together, not glued together. So, this is 7 to the 1 first, this is m to the negative 4, and this is n to the second. So we have to decide, does it stay or go down? Okay, ready? Here we go. 7 to the first power, that's a positive exponent, so it stays. It stays on top. So we're going to write 7 to the first power. Then I see m to the negative 4 power. Ooh, bad attitude, bad attitude. It's going to have to go underneath. So it's the m goes down but becomes positive because it had to go underneath. Once it changes floors, it becomes the opposite. It becomes positive. N squared, that's a positive 2, so that n will stay right where it is. There you go. Let's do another one. Not glued together. Not glued together. So, 4 to the first, y to the first, x to the negative 3. Okay, see if you can do this. Stay or go down? Stay. That one stays because it's positive 4. How about the y? This stays because it's positive 1. Before I just said because it's positive 4. That had nothing to do with it, I'm sorry. The reason the 4 stayed is because the 1 is positive. X to the negative 3, that needs to go down. So the x will go down and its attitude will change to positive 3. Alright, what happens if we have a negative on top? Well, here's what happens. The n to the negative 5 power, that is going to go down below and join the y squared. So the y squared stays where it is because it has a good attitude, but the n to the 5th power will join it because it did have a bad attitude. Now, don't forget, there's an invisible 1 above, and in the Vinculum video we said that that was mom. Mom is always on the 1st floor, and the invisible 1 of dad is always on the 2nd floor. There are actually 6 problems I want to make sure that we look at on this slide. So, what if we have a parentheses to a negative power? Well, here's what it means. First of all, that negative means that we take this whole parentheses and change its position. So it becomes 1 over parentheses pk to the positive 5. Now, for now, you can leave it like that. Later on, you're going to find out that that will equal 1 over p to the 5th and k to the 5th. But for now, it's okay if you just leave it in its parentheses. But it becomes positive when it goes down to the basement. All right, remember this one. They're not glued together. So this is really p to the 1st and k to the negative 5. So the p stays up, but the k goes down, and it becomes positive 5. They're not glued together. There's your answer. On this one, we have the p has a bad attitude, so the p has to go down below, so p to the 5th, but the k to the 1st stays on top because it has a good attitude. It does not have to move. Let's look here. Here we have a bad attitude in the basement. Remember from the video, if the attitude's bad in the basement, then the dad sends it upstairs to have a better attitude. So this will go upstairs with the 1, and it will become x to the positive 8. And you could just say x, you can just say x to the 8th power. You do not have to put the 1 in front. Okay, what happens if we have a parentheses and the negative exponent is outside the parentheses? Here's what I want you to do. The negative exponent means change places or reciprocal. So we're going to flip this parentheses and we're going to make it 5 over 3. Okay? Now our exponent will be positive. We can evaluate this by writing 5 to the 3rd power multiplied, 5 over 3 is what I meant to say. 5 over 3 multiplied to 5 over 3. That equals 25 over 9. That's my answer. Now, some of you, here's another way to look at it. Flip this, right, and square it. What's 3 squared? 9, except it has to be flipped. And what's 5 squared? 25. Again, it has to be flipped because of the negative. But we squared the numbers, we just did the reciprocal and flipped where they were. Lastly, we have this. This last one means that you're going to take negative 3/5, that parentheses, and multiply it to itself twice. And this is positive, so I do not have to flip. Negative 3 multiplied to negative 3 is 9. 5 times 5 is 25. So this answer is positive 9 over 25. Here are the practice problems. Please make sure to do all of them and show any work that you have and bring any questions that come up to class next time we meet. Take care.